Hi there, this is Maher Haddad here again. So in this lecture I have to speak about the OSI model. What is exactly the OSI model and where do we use it normally? So you already know that in case you work in a network environment, you always hear about layer 1, layer 2, layer 3, layer 4. So what are all those? So this is the lecture where I speak in details about the OSI model. So first thing to remember that the OSI model is 7 layers. Now, before I start speaking about what is exactly the OSI model, I just want to let you know that before, when the networking has started, that people do networking in their companies, for example, then each company, each manufacturing company was creating the devices or the network devices based on their own model. So there were no one model which works for all companies. So what happened here in this case, that let's say company X create the networking devices on their independent models, company Y created network devices on its model. Then in case one company buys equipment from company X and from company Y and they put it together, then they will not work together. So they were not compatible to each other. That's why they have decided to create one model which works for all the companies, and they have to follow this model. So every company which is creating network devices, they have to follow the OSI model. All right. So that's very important to remember. So that's like a standard that every company, when they create the network devices, but not only network devices also. So some companies, they will only create, for example, the layer 2 devices, some create layer 3 devices. All of those companies, they have to obey to the OSI model. So that's the real idea of the OSI model. So it's a standard that all companies, when they want to create any network device, they have to follow the OSI model. Then in case one customer buy any equipment from any of the companies, so let's say now if you buy MikroTik equipment and you put it with Ubiquiti equipment and you put with it Cisco equipment, you see that they all work together without any problem. Why? Because they follow the OSI model. So that's just an idea what is the OSI model. Now, let's dig more inside the OSI model to understand what is it exactly, the OSI model. The OSI model consists of 7 layers. And the layers, you have to count them from bottom to top. So that means we have to start here. The first layer is called physical, and this is layer 1. The second is called data link. The third is called network. The fourth is called transport. That is 5, 6, 7. So you have application, presentation, session, transport, network, data link, physical, and you have to remember them. Now I know that it may be a little bit difficult to remember them. That's why I have put this for you, so you can remember this sentence, and then based on this sentence you can remember the OSI layer, which is all people seem to need Diet Pepsi. So that's not difficult to remember. All people seem to need Diet Pepsi, or all people seem to need data processing, for example. All right, so that you take the first letter from each of the word, and this A means application, P means presentation, S means session, T means transport, N means network, D means data link, and P means physical. All right, so again, remember, all people seem to need Diet Pepsi, and then you start from layer 1 is the bottom one, and then you go up. So when someone is speaking about layer 1, then we are talking about the physical layer. When someone is speaking about layer 2, like switch working on layer 2, that's on data link layer. I'm gonna explain to you what each of the layer do, but just for now, remember what I'm saying. So if someone say that I'm working on a switch or working on the layer 3, that's on the network layer, and each of the layer has a function. I'm going to speak about it in a moment. Now, this is the transport layer on layer 4, session is layer 5, presentation is layer 6, and application is layer 7. All right, so that's very important to remember. Application, presentation, session, transport, network, data link, and physical. Now, we know what is the OSI model, what is the main function of the OSI model, and why we have created it. And we know the 7 layers that we have. We count them from down to up, and we remember all people seem to need Diet Pepsi. We know what are the names of the layers inside the OSI model, so those are called layer. Each one of these is called layer. So now let me explain to you what is the function of each of the layer. So when the OSI model was created, and actually it was created by the ISO, which is a standard community. So when it was created, I think it was in 1984 or 83. I'm not very sure, but maybe 84 or maybe 83. But anyway, when it was created, they said that each of the layer has a function. All right. So in this case, we have to remember what is the function of each of the layers. Let's start with the first one. This is layer 1, which is the physical. Physical means everything which can be touched, like the cables, like the connector, or maybe not touch when we, for example, have the data which needs to be sent from one computer to another. They are sent by bits. So bits also is on physical layer. So just remember, physical is everything which is like voltage, like clock, like connectors, cables, the bits, those fix inside the physical layer. Now, the data link layer, which is layer 2, is the layer which mainly make the error detection to be able to be sure that the data which is sent to it doesn't have error. And over there also on this layer works the MAC address. So that's why we say switch is layer 2, because the switch on layer 2 works on MAC address. This is the addressing that the switch use to be able to send and to receive the frame. All right, so this is what the data link layer. The layer number 3, which is called network, it is the layer which works for everything which is routing. All right, so that's why the router works on layer 3. All right, that means in this case we have to think of IP address, because the IP address is the address which is used to be able to make or to send the packet from one source to the destination. So layer 3 is everything which is inside the routing. So remember, we have the network layer, which is routing, and the data link layer, which is switching. Now you have some switches which works on layer 3, and those are, we can call them router switch, because when the switch works on layer 3, it's not anymore a normal switch which works on layer 2. It also has capability to do routing. So that's why we say layer 3 switching. You get the idea. Now, after that, we have the transport layer, which is layer number 4. And the transport layer is responsible for the data to how to be transported to the other side. So we have two important protocols that works on the transport layer, which are the TCP, so the TCP, and also we have the UDP. TCP is reliable. That means that once you want to transport data from one computer, for example, to another computer, it will check that this data has been received successfully to the destination. All right, so protocols, for example, like HTTP, like FTP, those are working on the TCP, so they are reliable. The UDP is unreliable. UDP means it will know that it has to send it to that destination and it send it. In case it is received, it's good. In case it doesn't receive, then no problem for it. So that means the destination doesn't ask to send it back. The UDP doesn't have the functionality, while the TCP do. So the TCP, in case the data is not received by the destination say, I didn't receive this segment from you, please send it back to me. So you send it. That's on TCP. On UDP, this is not the case. All right. So why do you use UDP? Normally we use UDP when we use something like the videos or the call, when we do VoIP, for example. They work on UDP because you cannot, when you make videos, for example, video conference, in case the segment is not received to the destination, it's not possible that he asks him to the source to send again the segment which was not received, because then you have delay on the video. That's why a lot of times when you are doing video conference and in case your internet is not very fast, you may see some outages on the video, and that's normal. All right. So now again, remember layer 1, layer 2, layer 3, layer 4, and then we go to this session. That is layer 5. The session means that when you, for example, go to your computer and you want to go to a web page, you write, for example, www.google.com. Then what is going to happen, this session will remember the session that you have opened to that web server, because of course a lot of other users are also on this web server, which is google.com. So this session will determine what is the session which is open with the server. So that's what is the function of the session. Now the presentation is once you, for example, go to the web browser and you go for a website, then it will present the data format. Okay, normally the format is working on ASCII table. So that's how the computer works. It will only make the data format ready. All right, so that's what is the presentation. It will present the data. All right, so that's how you can think of it. And finally, we have the layer 7, which is the application. So that means here we are talking about the HTTP or the FTP or the SSH or the Telnet. So whatever the application you are using, this is on the application layer. So as a review, we have to start back to physical. Physical means bits, voltage, cables, connectors. Layer 2, which is the data link, is making the error-free for the data, and then also there works the MAC address. The network layer is the routing, and here works the IP, for example. Layer 4 is TCP or UDP, so it's reliable or unreliable transport of the data. Session is to make the session ready. Then presentation is to present the data, and then application, which application we are using. All right, so now we know and we understand what is the OSI model. Let's see now, in case you have to do a transmission from one computer to a web server or to any type of server. So how this happened, and this is what we call it, the encapsulation and de-encapsulation. So let's say we are now working on a computer and we want to send something to a web server. So this is us over here and this is the web server. All right, so we go to the computer and we go to the browser and we write www.google.com. So then I will click enter. First it will go to the application layer. Application will say, oh, that's an HTTPS, that's the application. And then it will add a header to the data that we want to send, and it will go down to the presentation layer. Presentation layer will present the data format. It will add its header and it will send it down to this session. This session will say, oh, we are opening a session to google.com server. It will add its header and it will send it to the transport layer. The transport layer will check, oh, that's an HTTPS, and HTTPS works on the TCP because TCP is reliable and HTTPS works on TCP. So it will add its header, which is saying here, we are going to use TCP to make the transport, and then we'll send it to the network layer. The network layer will see, okay, from which source to which destination on layer 3 means on IP I'm going to use. So he will add his IP address here, and he will add the destination IP address, which is the IP of the Google server. And then it will add its header and send it to the data link layer. The data link layer will check, oh, we are going to google.com. Let's see the MAC address. I will add my source MAC address, and I will add the destination MAC address. In this case, the destination MAC address is not going to be the Google. It's going to be the MAC address of the router that we are connected to it. But that's for him a destination MAC address. And it will check if there is any error. And then it will send it to the physical. The physical make it bits. And then this is sent to this guy over here. So what is happening here, this is called encapsulation. So when it's going this way, that is what we call it, encapsulation. All right, that's very important to remember. Now when it receives to here, it is encapsulation. It has to do de-encapsulation. That means it will check on each layer and it will remove the headers that here was added. So the physical, it will remove the physical header and send it to the data link. The data link, it will check what is about, the source MAC address, the destination MAC address, and it will remove it and send it to the network. The network layer will remove the header of the network layer that was added from the source, and it will send it to the transport. The transport will remove the header and send it to the session. The session will remove the header and send it to presentation. Presentation, remove the header, send it to application, and then here it will come to the web server. So that's how normally the things happens when you are working on a network. All right. So this is called, when it is this way, it's called de-encapsulation. Okay. So this is in de-encapsulation, and this is this way down is called encapsulation. So that's very important to remember. And every time you are sending anything on the network, this is how it works. Encapsulation, de-encapsulation. You cannot skip any of the layers because this is how it works. So you have to follow this way. So it's the same as you are sending a letter in a post. You have first to get the letter, you have to write it, you have to put it in an envelope, you have to go put it in your box. Then the postman comes, take it from the post, and he take it to the company, and then there you see what is the address that it's going to be sent to. Then they will go to that address, they put it in the box, the receiver will open his box, and then he can see this letter. So this is the same. This is the structured layer that a post office can do. The same on the networking. This is the structured layer that the data has to pass through in order to be sent from one place to another. Now, the last thing that I want to speak about in this section is the PDU, the protocol data unit. When we are on this level, on the physical layer, all right? So here the data is called bit. So the data with the headers, okay? So here is called bit. So whenever you say bit, then you are talking about the layer 1, the physical layer. When the data with its header is on the data link layer, that is called frame. So when you are speaking about switching on layer 2, you don't say packet, you say frame, because on layer 2 it's called frame. When it is on the network layer, the layer 3, then this is called packet. All right. So when you are saying a router is sending a packet, because router work on layer 3 and not on layer 2. Now the transport layer here is called segment. So that means the data with its header here, when it is on the transport layer, is called segment. And the last 3 over here, all those 3, we call them data. Okay, so that's something to remember about the PDU, the protocol data unit. When it's on physical, it's called bit. When it is on data layer, it's called frame. When it's on network, it's called packet. When it's on transport, it's called segment. Now, how to remember it? What I do to remember it is I have to remember those bit, frame, packet, segment. But then B on the alphabetic order is before F. F is before P. P is before S. So that's how it's easy to remember it: bit, frame, packet, segment. All right. So that's very important to remember the PDUs. That's how we have to remember them. So this is what I wanted to explain about this lecture. It's all about the OSI model. Remember, the OSI model is a layered approach that companies used when they want to create any hardware or software. So they have to follow the OSI layer to be able to be compatible with all other network devices that are made or software made from other vendors. And I have explained to you what are the 7 different layers that we have. All people seem to need: Diet Pepsi, application, presentation, session, transport, network, data link, physical, and what is the function of each of one. And then I have explained to you what is the encapsulation and the de-encapsulation and how it works. Then I have explained to you regarding the PDUs. So what is the name of the data with its header when it reaches any of the layers. So this is what I wanted to show you in this lecture. So it is all about now theory. So I hope that this lecture was informative for you, and I will see you in the